Okay, this is a multiple part mental array and point cache export Q&A for 3D World. Starting with the MR Proxy baked start Mac scene, which is basically the result of a previous tutorial or Q&A for 3D World that I wrote a few years ago. Okay, so basically what we have here is a 5-second duration sequence that basically generates a animated speaker, thus based on a controller. However, what happens if we actually want to distribute this speaker millions of times, or not even millions of times, maybe a few thousand times or something, throughout the scene using mental array? Now, the problem with that obviously is due to the polygon count, the actual sheer size of it might fall over at render time. So what we can do is bake the entire thing out to Makuta Proxy. Now the things with Makuta Proxies is that you can only bake out one single object at a time, so therefore you'd have to bake out a Makuta Proxy for every single individual item. So for example, this guy here, this guy, this one, and so on and so on. So therefore what we need to do is to collapse the entire thing down to a single object, and then using the original deforming object we can simply offset the geometry and then bake the entire thing out. So to do that, what we need to do is we need to collapse the entire thing down at frame 0 to a single object. Let's just bring that around here. So if I grab the entire lot there minus the helper, I can simply make sure I've got everything there. Let's just go to select by name. Yes, I do. I've also got these guys, get rid of them, and I can simply copy that, and then I'm going to break any links that we have already set up in there. As it currently stands, we're more than likely still animating, quite simply because we've got a linked text form in there, this guy here. Now obviously, what's the original, where's the other one? There we go, yeah, still got the linked text form in there. So obviously all this needs to be collapsed down so the geometry isn't animating at all. So need to make sure that we've got everything chosen still, and then I'm simply going to collapse everything down to an editable poly. So that's now this guy here, and you notice that even though the audio is playing, you still won't get any animation in there because all the linking's been broken, which is what we want. So next thing we need to do is to collapse everything down to one single object. So I'm just going to pick this base speaker magnet 01 object here, and then attach everything that's within the viewport that I've got isolated here. So I'm just going to go to attach and then just drag in all those guys, and then this is the most important thing: attach objects, we match the material ID to material. So basically it's collapsing everything down but also maintaining the same materials that were assigned to it now as sub-object materials. So therefore what we can do then is pull in the resulting sub-object material, which is by clicking on this little eyedropper here, which then samples, just moved, the entire material set. Notice how this is different compared to the original materials which are originally assigned. Okay, so all the materials and all the mapping is still maintained within this particular object, however it's now referenced as a multi-sub-object material. Okay, so the next thing we need to do is to reference all of the sub-object geometry, i.e. the elements here, with the original model here. That's quite a straightforward procedure. Now we only really need to do that on objects which are actually moving or are deforming. So therefore there are about 2 or 3 objects in here which are moving. One is obviously the diaphragm here, one's the cone, and one is this little speaker cap in the middle here. Everything else is pretty much static, so we only need to apply 3 separate linking or wrapping modifiers to it. Okay, so let's just make sure we've actually got our main collapsed object that we have. Here we go. Okay, so what we need to do is select each one in turn and assign each one in turn to the relevant deforming object. So in this case, I'm going to simply select this element here, which is this large cone surface assigned to the corresponding cone by using a skin wrap. If I just pull this down, there we go. And then because we've actually just got the sub-object element selected, this little cube icon pops up here because we've got the element selected. We can now just assign, let's do it by name, the speaker cone. You'll notice that it now starts performing the parameter data build. This is Vista just updating, and we now should have the sub-object cone is now deforming, which is being driven by the original cone object. Okay, you notice however that this guy in the center, the collapsed version, is not moving at all. Notice this white area here is not shifting at all. So obviously we need to go through and apply the same kind of procedure to that. So that's a simple case of just going through and just putting in a poly select. Let's grab that. Now we just need to make sure we're all the way back at frame 0 again, and choosing the element, and then choosing the relevant element within the scene, within the object even, and the same deal as before, going to where are we, skin wrap, and then choosing the speaker cap. There we go. Okay, so now this should be deforming as well. There we go. And then the last thing to implement is this diaphragm back here. So one last thing to do, let's just go back to poly select. There we go. Again, making sure we're getting the right object chosen, which is this diaphragm here. And then again going to skin wrap, and then choosing the speaker diaphragm in there. Again, takes a little bit of time to build up the parameter data, quite simply because there's more geometry than there was in the original cap. This is just, again, it's Vista just thinking that it's locked, but it actually hasn't. There we go. Okay, so now what we have is our speaker, which should now all deform. If I just turn edge faces on, we should be able to see the entire thing. See, it distorts. It takes a little bit of time to update, because obviously it's got to update the skin wrap for every single one of these objects. So for this guy, this guy, and this guy, it takes a little bit of time to update. However, we don't need to worry about that much anymore, quite simply because we're going to bake the entire thing out to either Mental Proxy, or you can bake it out to a point cache. Now the best thing really at this stage is to make sure you've got this any sub-object information cleared. So I'm just going to go back to poly select and just apply that at the top to make sure that the sub-object selection is actually cleared. So if you actually want to bake this out to a point cache, what you can simply do is just apply a point cache modifier there. Let's create a new one. I'm just going to drop this in. Let's call that speaker export. There we go. And obviously the cache file has not yet been recorded, so it's simply a case of just going through and recording the entire thing. I'm just going to pull that back there. So I'm going to do one file. You can actually do one file per frame, which actually cuts down the amount of loading that the system has to go through. But in this particular instance, I'm just going to use one file. So I'm just going to go through and record, and that will go through and record every single frame based in the entire scene. Now notice if it thinks it's locked up, it's actually just going through the entire sequence. And the sequence is done, and that simply results in, I've just pulled this across here, you can see we've actually got a 78 meg, well, close to 79 meg point cache file. Okay, so what we can do now is obviously disable all the modifiers below, so that simply goes through. You can see it just calls it straight from the disk. You notice the audio is still playing. That's quite simply because of the noise controller that's actually loaded in. So I'm just going to mute that because I'm sick of hearing my own voice. Okay, there we go. Okay, so we can just scrub that back and forth, and it updates quite nicely. Okay, so again, bearing in mind we've still got all the geometry in there. The relevant parts are obviously deforming accordingly, like so, and it's all baked out to a cache file. Now that's one way of going through it. The second way of going through it is to bake the entire thing out to a metal array proxy. So in this particular instance, I'm just going to go and save this out for a second, so you guys have got this. So I'm just going to call that finished point cache. Okay, I'll go through and save. Okay, so the next thing I want to do is I want to kill that modifier because it's not going to be relevant anymore. I'm going to turn all this lot back on again, back at frame 0, turn all that lot back on, and now what I'm going to do is I'm simply going to go and create a mental array. Where are we? Here we go. Mental array proxy object. I'm just going to create that in the perspective viewport, or you can create it in the top viewport, so you make sure that your axes are actually aligned correctly. Now there's a high possibility that because the local axis in this is pointing straight up, you notice, let's make sure I just put it on move tool so you can see exactly where we're dealing with. So the z-axis is actually pointing straight up, y-axis is going that way, x-axis is going this way. Now for the actual object itself, they're actually pointing in the opposite direction. So therefore, when we actually bake this out, this will actually be orientated in the opposite direction. It will more than likely be orientated, well, Z is that way, so therefore it will be orientated about 90 degrees out. So therefore what you can do is simply go through and check, well, bake it all out first, see how it goes. If it doesn't work, you can always apply an X form to this to make sure that it's orientated the correct way. Personally, I always tend to prefer that to make sure that the axes are pointing in the correct direction. Okay, so first thing we need to do is choose our source object, which is by clicking on this none button and then choosing our speaker. Now obviously we can't see anything in the scene at the moment, quite simply because nothing's been written out to the file yet. So we obviously need to chuck this out. So the first thing you do is obviously by clicking on this right object to file, the first thing that pops up is a warning to say that the mental array proxy feature only works when mental array is the current renderer. So therefore let's go through and just quickly change that. So I'm gonna just pull that down there and change the current renderer to mental array, close that guy and then give that another go, and then let's create a new folder and call that MR speaker proxy. And we just give it a file name. Let's call it MR proxy speaker. Okay, now we have a choice of using the current frame, which is obviously just one single frame, and then the active time segment, which is producing one file per frame, or a custom range, which is the one file per frame. Now I'm going to use the active time segment, so it's got the full duration of the sequence that's going to be output into this particular folder that we've just created. Now this will actually create quite a substantial amount of data. The files might be quite large, so hopefully we'll have enough space to include this with the CD. If not, then I apologise in advance. You'll have to bake this out yourself to get past this particular stage. So I'm just going to click on this OK button, and what it will do now is it will go through and simply render out. I've got a missing map error, but oh, it's just looking for the audio track. WAV, don't worry about that. Okay, so now what it's going to go through is generate this speaker cone for every single frame within the actual sequence. And the metal ray proxy is now baked out. It takes a little bit of time to output, quite simply because of the amount of frames and the amount of geometry detail. We've got some nice kind of thumbnails that are produced on this. So if I just isolate the selection, we can simply just scrub through. You'll see the points update in the viewport, and also the thumbnail update as well. This is obviously, each point is obviously caching from the disk, so therefore the least amount of points you have, this viewport verts here. If I dial that down, you obviously see it update in the viewport. If I take that down to about, I don't know, 50, it will update considerably faster than if I crank it all up. So let's crank it up to its highest amount. So you'll see it update a little bit more slowly. It's obviously got to load in more information from the disk. Okay, so I'm just going to put that back to 1000. And like I said earlier, if you want to reorient this thing, just come out of isolation. There we go. Okay, so if you actually want to make sure that this is orientated the correct way, or the same way as this, make sure that you actually have an X form on this when you bake it out for the first time round. Okay, right, so the last thing we need to do, because if we actually just decide to render this guy out, I'm just going to isolate that again and just render out a single frame. You'll notice that once max decides to update, there we go, it's now loading it from the disk. You'll notice that there are no materials assigned to the thing. Mental ray proxies don't actually record the materials that are assigned to it. It only records the geometry. So what it does do, it actually retains the mapping coordinates and also the sub-object information. So therefore what you can do is simply reassign the material that we sampled earlier on, which is obviously this guy, straight to our object. So just click on that, and then if I render out a frame again, this is just looking for the audio track. There we go, we've got the exact same materials and the exact same mapping applied as the original. So if I just choose the original collapsed one and just render out a quick test frame again, we can do a direct comparison between the two. There we go, exactly the same. So what we can do now, if I just save this out as, let's call that, actually before I do that I'm just going to come out of isolation and save it out. There we go. Let's save that out as proxy bake finished Magadheera proxy, and then if I now invert the selection, make sure that I don't have the lights selected, and I can then delete that, swing this back round. Okay, and then I'm simply going to duplicate this several times. So I'm just going to set this back to the origin first. And then using snap, I'm just going to create several copies of this. Let's say, let's do 20, or so we've got 19 in that direction. And then let's do another 10, well, another 9 in this direction. So we now have a huge wall of speakers, and this is where metal ray proxies tend to come into their own. Okay, create a camera there. I'm just going to make sure I've got the light covering all the speakers, which I obviously don't at the moment, so I'm going to make sure I've got that set up. Increase the fall off. Okay, maybe a touch more. change the lighting to ray traced. Just gonna amend this so the shadow's nice and tight. Go back to our camera, turn safe frame on, and now we should have an absolute ton of speakers. So you can see they're all animating, working quite nicely within our final render. So it goes through the final gathering. It takes a little bit of time to go through on the first frame. And then quickly goes through the actual final render itself. Now you'll notice that when we're rendering, you can see the actual number of faces is set to 0. Quite simply because there is no actual physical geometry within the scene. It's all been pre-baked out to disk. Okay, so there we have it. One set of multiple part animated objects, all baked down to one Magadheera proxy file or one point cache file, whichever one you choose. Thanks very much. Cheers.